Now we're going to do a quick review of geometry, and I've seen a lot of distance formulas and Pythagorean theorems, so I think that's really the most likely thing you are to see on your TSI. I'm not sure. I'm not a TSI expert. I'm just an expert at math, all right? So distance formula, if you've ever had my geometry class, you will know Mrs. Overman is not a fan. And that's fine. Some of you are like, I love the distance formula. Enjoy. Do you know why I actually hate the distance formula? Invariably, I'm going to mix up, like put an X with a Y, or have for some reason, when I'm doing this, it's just so much easier for me to make a mathematical error. I'm much happier with a much simpler formula for distance, which is Pythagorean Theorem. And I'm going to show you how to do it. So I'm going to assume most of you know how to use the distance formula. I'm going to just show you the Pythagorean Theorem method. So let's say I'm trying to figure out the distance between these 2 points, 1, negative 2, and 4. So it's not, I don't have to be perfect on these. Okay, so 1, negative 2 is right here, roughly. And negative 5, 4, it's positive 4, is up here. And I want to know what this distance is right here. Now the smart thing to do, well, you could do distance formula and that would be fine. But I like right triangles. They're pretty awesome. Because then they let me use Pythagorean Theorem. In fact, I like Pythagorean Theorem so much. My dog's name is Pythagoras. All right. So how big is this length here? If I'm at, here I'm at 4, right? I'm at negative 5 comma 4. And here I'm at 1 comma negative 2. So to drop down, we're all the way to negative 2. So this distance right here is 6. And to go from negative 5 to 1, that is also 6. So using Pythagorean Theorem, if I use c for my distance, c squared equals 6 squared plus 6 squared. Well, hopefully you know 6 squared is 36, and when you add 2 of them, you get 72. So c is square root of 72. And if they have that as your answer, you're happy, yay, go ahead and circle it. But they could have it in a simplified radical. So how do we do that? So if I can rewrite that, do you guys remember doing factor trees when you were in middle school? 72 is 8 times 9. 8 is 2 times 4, 2 and 2, and 3 and 3, right? So if I multiply all these out, you can see that, where do I have some perfect squares? I actually have it in here, and then I have an oddball too, okay? So the oddball is what's going to be left in my square root when all is said and done. I can actually write 72 is the same as square root of 2 times 4 times 9. Does that make sense to you? And you can actually do this with square roots. I can say that's the same as square root of 2 times square root of 4 times square root of 9. Square root of 2 is irrational. People have died over it. Square root of 4, on the other hand, is pretty easy. It's 2, assuming we're doing positive roots. And square root of 9 is 3. Now, we are biased in the mathematical world. Irrational numbers are considered second class. They go to the back of the answer. So 2 times 3 is 6. That's a nice rational number. In fact, it's an integer. It's gorgeous. But square root of 2, the sad little irrational number, it's pushed to the back of the bus. So that is the distance. So you might actually see that as your option instead of the square root of 72. All right, we have, what is the distance from the ramp's contact point with the ground and the base of the platform? Here's the base. So they want to know the base of the platform, not the top of the platform. All right, so they're trying to solve for x here. Again, hopefully you recognize this is Pythagorean Theorem. So the nice thing about Pythagorean Theorem is it doesn't only work for coordinates, it also works for triangles, so it's multi-use. Less stuff to memorize. I've dropped my square there. Now, if you are familiar with the 5, 12, 13 triangle, you might be tempted to say this is 13, right? Because it's a very popular right triangle. Problem is, this leg here cannot be longer than that 12-foot hypotenuse. That is not 13. So if you had put the 12 over here and the x over there, you'll get the wrong answer. No, this is an ugly answer. It is x squared, and 14 minus 5 is 9. 13 minus 2 is 11. So x squared is 19. The distance is square root of 119. That is not a pretty number that I can easily factor, so I stop there. That's my answer. Now, another very important triangle, some of you see this 3 and this 4, and they want to know what this is. All right? If you see a 3, 4 blank triangle, and it's a right triangle, and the blank is the hypotenuse, hopefully you remember that this is the 3, 4, 5 triangle. Now, if you forgot, it's okay. You can say x squared equals 3 squared plus 4 squared. It'll still work out. So that means x is the square root of 25. And since we only have positive lengths, x is 5. 3, 4, 5 triangle, one of the favorites of all teachers. Now, let's say you had a three-dimensional box, and they wanted the distance from one end, let's say here, we'll start here, to here. All right? So if I was cutting across this corner to that corner. Well, currently, let me go ahead and pretend that I'm just going to cut across this way and then join up. All right? And we're going to pretend that this length is 3, this length is 4, and that length is 12. Well, what I can do is 3 and 4, hopefully you recognize, hey, 3, 4, 5 triangle, that's 5. If I take this slice out, it's actually a right triangle. 12 is already there. There's there. And so it's another special right triangle, and it's x. So I can say, oh, x squared equals 5 squared plus 12 squared. 25 plus 144, 169. And hopefully that 13 squared is 169, so x is 13. The distance is 13. By the way, there's a 3D version of the Pythagorean Theorem. You can do this as a shortcut if you feel like memorizing it. So when you have 3 legs, like 3 and 4 and 12, you can just square them all up, add them all up, and pretty much do the same thing. It's just you have an extra dimension. Look at this. So 9 plus 16 plus 144. 25 and 144. Oh, look, I'm already kind of it looks like that. 169. Isn't that amazing? And so my distance is 13 as well. So 2 ways to solve that problem.